Hi friends, welcome to JMK Tutorials. So just we have to find out the integrator gain also actually in this session we will find out the output voltage up to now. Okay, let us see the what is the gain of this one. Okay, generally gain means how can you find out that open loop gain? This is nothing but ACL, right? ACL is equal to output by input, right? So it is also represented in terms of ZF by Zi, where ZF is equal to the impedance of the capacitor. This 1 by it can 1 by SCF, where Zi is equal to normal resistance R. Therefore, ACL is equal to 1 by SCF by R. Okay. Therefore, it is equal to minus 1 by J omega R CF, where S is equal to J omega. So if you are replacing S with J omega, we can write this one. This is a uh, gain for integrator, or else we can also represent this equation to J to the numerical point. Therefore, ACL is equal to also. So minus J is there. So instead of that, we can place minus elements. Minus can be represented as J square minus 1 J square. Therefore, so I will write here, just it can be represented like this also. So this equation can be represented as equal to minus 1 can be represented as J square by minus J into omega RCF. J get cancelled, minus, so okay, so this is actually plus actual. Okay, this is plus, we don't neglect it, just we can also replace this one. Okay, therefore from this equation it is equal to, so just I will erase it. Therefore ACL is equal to J by omega RC cube. It is a closed loop gain for integrator. Okay, now let us see the scenario for differentiator. So what is meant by differentiator? Differentiator is a quite opposite to the integrator circuit. Just first of all we have to draw the circuit diagram for differentiator. So it is similar to the integrator, just variation in the feedback path only. So this is the operational amplifier. Just instead of resistance, we can connect the capacitor. So here I will connect the resistance as a feedback. So this is the only difference in case of the differentiator. Okay, so this is a current I1 I will call, entering current is equal to I2. Okay, so I will connect it to the ground. Okay, so it is inverting, it is non-inverting. So from this equation I will represent A. So from this we know that generally virtual short concept, VA is equal to 0, KCL at node A I1 plus I2 equal to 0 is the KCL equation. So here C into dVi by dt. So this is nothing but voltage equation. Voltage because capacitor I value is equal to dVc by d by dt and as well as C value. This is a generalized formula for capacitor current equation. Okay, so from this I will represent yeah, and I2 is equal to at voltage difference of, that is nothing but output voltage minus 0 by voltage difference by feedback resistance, or it gives rise to 0. So from this equation, I need only output voltage V naught by Rf is equal to C into dVi by dt minus NSL. Therefore, output voltage V naught is equal to, if you are taking the RF value to the right side, therefore, this I will write here. Therefore, output voltage V naught is equal to, this capacitor comes to right side, minus RFC into dVi by dt. This is our equation for capacitor. Okay, integrator circuit. Okay, therefore this is a voltage, output voltage in case of the differentiator. Okay, in case if you want to find out the gain of the differentiator, just to see the gain of the so what's the gain of the differentiator generally? So if you want to find out the gain of the differentiator, first of all you have to know the what is meant by gain. So gain is in a closed loop with a feedback V naught by Vi. So it can be represented as a ZF by Zi, where ZF is nothing but normal resistance or Rf, and Zi is equal to 1 by Sc. Okay, this is a capacitor equation, 1 by Sc. So from this equation we can write ACL is equal to closed loop is equal to feedback resistance Rf by minus Rf by. So it is in terms of negative sign is there because of it is a inverting terminal, minus Rf by what's the value, 1 by Sc. So it can be represented is equal to minus S RFC. This is the equation. Therefore, ACL is equal to J omega RFC. Okay. Therefore, so ACL is equal to minus J omega RFC. So this is nothing but transfer function of the differentiator. Okay, this is nothing but a transfer function of the so gain means generally output by input is generally called as a. So in terms of the omega values we can represent therefore transfer function of the differentiator. Okay. At the same time, some just you have to see the some differences will be there. In case of the, I will write here. Integrator differentiator output, integrator output. In case of the differentiator, let us see the what is the inputs. If you are applying the square wave, it produces the output of in the form of a spike section. So this is the output. If you are providing the triangular it produces a square wave output. If you are providing a sinusoidal signal, it provides a cosine in inverted. So this is a input and outputs for differentiator, and if you see the input and outputs for integrator, just if you are providing a square wave input which produces a triangular output. Okay, if you are providing the spikes format, so which gives the output of like this, and if you are providing a sine wave, it produces a cosine. Okay, these are the inputs and output in case of the integrator and differentiator, as well as gains of the corresponding integrator and differentiator circuits. Okay, thank you for watching GMK tutorials. Thanks a lot.